Module 5, Chapter 3.3, Quadratic Equations and Inequalities. An equation that can be written in the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not 0, is a quadratic equation in standard form. Consider the following. The zeros of the function f of x equals 2x squared plus 4x minus 16 are the values that make that function equal to 0. The x-intercepts of y equals 2x squared plus 4x minus 16 are the points where the graph crosses the x-axis, which means those points will have a y value of 0. And the solution set of 2x squared plus 4x minus 16 equals 0 are those x values that would produce the other side to be 0. So when we mention those, they are all three sort of the same thing. Each is solved by finding the numbers that make 2x squared plus 4x minus 16 equals 0 true. Now, we're going to discuss various ways to solve quadratic equations in one variables. Actually, we're going to talk about 4 in particular: the square root property, the zero product property, the quadratic formula, or the calculator method. Well, let's start with the square root property. The square root property says that solutions to the equation x squared equals k is equal to positive or negative the square root of k if k is greater than 0. It's equal to just 0 if k is equal to 0, and it's equal to a positive and negative I times the square root of the absolute value of k if k is less than 0. Now, right below that, we give examples of each. The square root property says if you have an equation of the form x squared equals a number, then we square root both sides. That undoes this square. So we get x equals, but we also have to consider the positive and negative square root of 9, which is 3. So we get x equals positive or negative 3. That's this case up here. The second case, x squared equals k, same thing. X squared equals 0. X squared equals 0. Square root, we have to consider the positive and negative. So we get x equals plus or minus the square root of 0. Well, square root of 0 is just 0. Positive 0 is the same as negative 0, so we would just have 0. Now, the third case, x squared equals negative 16. Something squared equals a number, so we're going to square root both sides. So we get x squared equals positive or negative square root of negative 16. Well, we learned x squared. We learned earlier that the square root of negative 16, the square root of a negative comes out as an I. The square root of 16 is 4, and then we have the two solutions, which are positive 4i and negative 4i. Now let's do a couple more. By the square root property, we need the number of the form something squared equals a number. Now, if it's not of this form, then the square root property is not going to work. Okay, so we've got to get it in the form something squared. So we're going to divide both sides by 2, which gives us x squared equals negative 5. Well, that's our square root property form. Square root this side, square root this side. Make sure you do plus or minus. So x equals positive or negative square root of negative 5. Well, square root of negative 5, the negative comes out as an I. We cannot simplify the square root of 5, so we get positive or negative I times the square root of 5. Now, what about the second one? Is it of the form something squared equals a number? Not yet, so we're going to divide this side by 2, divide this side by 2. So we get x minus 1 squared equals 7. Now we're of the form something squared. So we're going to square root that side. We can square root the other side as long as we remember to plus or minus. The square root of the square cancels, so we get x minus 1 equals plus or minus the square root of 7. Now we've got one more step. We've got to get just x on the side by itself. So we're going to go plus 1 plus 1. So x is equal to 1 plus or minus the square root of 7. Now, let's talk about type 2. Type 2 is the zero product property, or most of y'all are familiar with this as the factoring method. What the zero product property says is, if A and B are complex numbers and A times B is equal to 0, then either A is 0, B equals 0, or both equal 0. Okay, so this example says, use the zero product property to solve x minus 4 times x plus 3 equals 0. Well, it's already factored, so we know that either x minus 4 has to be equal to 0, or x plus 3 has to be equal to 0. Well, if x minus 4 equals 0, adding 4 to both sides gives us 4. If x plus 3 is equal to 0, subtracting 3 from both sides gives us negative 3. So our solution set would be 4 and negative 3. Okay, let's do a couple more by the zero product property. The first one, now you notice these are not in factored form, so step 1 is to get it in factored form. So we're going to go through greatest common factor is an x. If we pull out an x, then we get x times 3x minus 2 equals 0. Now it's factored, which means either x is 0 or 3x minus 2 equals 0. Well, if x is 0, there's our first solution. Second solution, add 2 to both sides, divide by 3, and we get 2/3. The next one, 2x squared plus 7x equals negative 3. Our absolute first step is we've got to get this equation set equal to 0. So we're going to take 3, add to both sides, so we get 2x squared plus 7x plus 3 equals 0. Now we're going to factor it, if it will factor. So we've got the first two have to multiply to give us 2x squared, so we'll do 2x and x. The last two have to multiply to give us a positive 3, and the outers and inners have to give us a positive 7, so we know that these are both going to be a positive. We can do 1 and 3. Let's just check and make sure they work. Outer 2 gives us 6x, inner 2 gives us 1x. 1x plus 6x does give us a middle term of 7x. So we've got it factored correctly, which means 2x plus 1 is equal to 0, or x plus 3 is equal to 0. The first case, subtract 1, so we get 2x equals negative 1. Divide by 2, and we get negative 1/2. Second case, subtract 3 from both sides, so we get x equals negative 3. Okay, one more. Use the zero product property to solve x squared minus 8x plus 16 equals 0. Well, let's factor it. So we get x and x. Signs, last two have to multiply to give you a positive 16, but to combine to give you a negative 8, so we know they're both going to be negative. The last two have to multiply to give you 16, so we'll do 4 and 4. Well, now if we go through and say, well, x minus 4 equals 0, x minus 4 equals 0, well, this one says x is 4, this one says x is 4. So what we've got is one solution, which means that there is one distinct 0. Now, all the other ones we've had two solutions, and this is an example of when we might get one solution. Now, how many solutions should we be looking for? Well, most quadratics will have two solutions. some will have one solution, and some will have none. And actually, there are no real number solutions, but we do have imaginary solutions. Now, let's go to method number 3, the quadratic formula. Okay, people say, do I have to know all of these? Yeah, because the factoring won't work because not all quadratic equations can be factored. The square root property won't work because all of them cannot be written as a product of, as a perfect square without going through a lot of steps. Now this quadratic formula, it's very long, but it always works. Okay, what it says is the solutions of the equation ax squared plus bx plus c equals 0 are found by the formula x equals negative b plus or minus b squared minus 4ac all over 2a. Now, before we start these, let's go back and talk about a part of this quadratic formula. The expression that was under the radical sign, the b squared minus 4ac, that is what we call the discriminant. And the discriminant determines the number of and type of solutions that the quadratic equation will have. For instance, if the discriminant, the b squared minus 4ac, is a positive number, we're going to have 2 real solutions. If your discriminant, b squared minus 4ac, is equal to 0, then we will have 1 real solution. If your discriminant, b squared minus 4ac, is less than 0, if it's a negative, then we will have 2 imaginary solutions. Now, we're going to go one step further. We're going to say if the discriminant is positive, then we can either have 2 rational solutions, or we could have 2 irrational solutions. Okay, rationals just means they're going to be like 3 over 2 and 5. Just nice, neat, pretty fractions. The irrationals may mean something like 2 plus or minus the square root of 5 over 7. These are going to be the ugly answers, those with the square root. And anytime we get these irrational answers, we usually want to enter these in decimal form. Okay, so here's a little discriminant chart that will help you if you can memorize this chart. The first column says if D is, now remember D is the b squared minus 4ac. If the discriminant is a positive number, that is a perfect square. Okay, a positive number that is a perfect square. So if D is 1 or 4 or 9 or 16 or 25 or numbers of this form, then we are going to have 2 rational solutions. Okay, 2 nice, neat, pretty numbers. And I'll give you a hint. If it's 2 rationals, that means that this equation was factorable. So if you're good at solving by the zero product property, then you may want to back up and do your factoring method. The second option is, what if D is a positive, but it is not a perfect square? Okay? What if it's positive and not a perfect square? That means what if D is 2 or 3 or 5 or 6 or 10, anything other than the list above? Then we're going to have 2 irrational solutions. Okay? Which in this case, they're probably going to ask you to put your answers in decimal forms. The third option is, what if D is 0? Well, then what you're going to have is 1 rational solution. That was like the one we did earlier where we got 4, but we got 4 that occurred twice. And then the last one is, what if D is negative? And actually, it doesn't matter if D is a negative perfect square or negative not a perfect square. Then we're going to have 2 imaginary solutions. okay, which means we're going to have i's in our answer. Now, it could be plus or minus 2i, or it could be something like 3 plus or minus I squared of 3 over 4. I mean, it doesn't matter how ugly they look, but we know we're going to have an I there. Now, do you remember we talked about solutions and x-intercepts being the same thing? Well, if you have two rational solutions, what that means is when you graph it, you are going to have two x-intercepts. So it's either going to look like that, or it's going to look like that, but you're going to have two places where your graph crosses the x-axis. Same thing for your positive not a perfect square. You know, you're going to have these two. They may be ugly, but you're still going to have these two solutions, or two x-intercepts. Now, if there's only one solution, then what that means is your graph is going to come down and touch right there and go back up, or it's going to come down here, come up and touch it and go back down. But in these, you'll just have the one x-intercept, and that will be your one solution. Now, what do you think imaginary solutions would look like in terms of x-intercepts? Well, there's not a real number for imaginary. So what we'll have is we'll have a graph up here that never crosses the x-axis, or we'll have a graph down here that never. So this is two x-intercepts. This one is two x-intercepts. This is one x-intercept. And this is no x-intercepts. So here we go. Determine the number of and type of solutions for 9x squared minus 12x equals negative 8. Now notice it says do not solve. We just want to know what are we looking at. So we've got 9x squared minus 12x. Add 8 to both sides equals 0. Before you do your quadratic formula or your discriminant, you have to have it set up equal to 0. Now, a is the number in front of the square term. B is the number in front of the x term. And C is the number. So, if we're looking at b squared minus 4ac, and we get negative 12 squared minus 4 times 9 times 8, that would be 144 minus 4 times 9 times 8. We're going to do 4 times 9 times 8, which is 288. So 144 minus 288 would be negative 144. D is negative, which means we're going to look for two imaginary solutions. Okay? Now, just to verify that, let's go back up here as y equals, and let's enter our equation. Now, what are we expecting? Because there's no real solutions, we are expecting this graph to never cross the x-axis. Now, remember, when you graph it in your calculator, you need to make sure you have it set equal to 0. Graph, and that's what we get. So you can't depend on your calculator to give us the solution all the time, because if it doesn't cross the x-axis, then there's not a solution on your calculator. Okay, now, let's do the whole big thing together. Solve by using the quadratic formula. Well, a is 2, b is negative 1, and c is 4. So we get negative b plus or minus the square root of b squared minus 4ac all over 2a. So it's negative b, and b was already a negative, so that means the negative of negative 1 plus or minus the square root of negative 1 squared minus 4 times 2 times 4 all over 2 times 2. So the opposite of negative 1 is 1 plus or minus. Now remember, negative 1 squared is always a positive. 4 times 2 is 8, times 4 is 32, so that's minus 32 over 4. So that's 1 plus or minus the square root of negative 31 over 4. Don't stop with the square root of a negative. Let's go ahead and call it 1 plus or minus I times the square root of 31 over 4. So this would be our solution, which are really two imaginary solutions. Okay, let's do another one. Now this one doesn't even look quadratic yet, but when we go through and multiply this out, we get x squared minus 2x equals 2x minus 2. Now anytime you see quadratic, you need to be thinking set it equal to 0. So we're going to subtract 2x from both sides. We're going to add 2 to both sides. So we get x squared minus 4x plus 2 equals 0. A is 1, B is negative 4, C is 2. So we get negative B plus or minus the square root of B squared minus 4AC all over 2A. So that's negative of negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 times 2. And that's all over 2 times 1. So that would be 4 plus or minus the square root of 16 minus 8 over 2, which is 4 plus or minus the square root of 8 over 2, which now if we went through and simplified 8, we could rewrite the 8 as 4 times 2, which would separate as the square root of 4 times the square root of 2, which would give us 2 times the square root of 2. So we get 4 plus or minus 2 square root of 2 over 2. Now if we factor a 2 out of all the terms, 2 goes into 4. 2 times 2 goes into 2 once. 2 goes into 2 once. So we get 2 plus or minus the square root of 2. Those are two irrational solutions. And they may ask us to give it to them in decimal form, or they may ask for reduced radical form. Okay, last way. How are we going to solve equations in one variable using the calculator? Okay, what we're going to do on this is like we've been doing. We're going to take the left side, set that equal to y1. Take the right side, set that equal to y2. And then we're going to find where they intersect. So we're going to call that 2x squared minus x plus 5. I'm going to delete everything that was left. Then we're going to let y2 be 0, which there comes your curve, your 2x squared. There comes the y2. Does it ever cross the y-axis? No. Therefore, it is no solution, or two imaginary solutions. Okay? Let's do another one. Let's do 3x squared plus x minus 6 equals 0. Okay? So we've got y equals 3x squared plus x minus 6, and then y2 would be 0. Now when we graph that, we do get the graph that crosses in two places, so we know there's two solutions. We're going to find them. Second, calculate. Number 5, enter, enter, enter for the first solution, and we get x is 1.3 if we round it to the nearest tenth. Now we're going to find the second one. Second, calculate. Number 5, enter for the first curve, enter for the second curve. We're going to move the cursor over to the intersection that we're looking for, and we get x is negative 1.6. So that would be our two solutions. Now, a quadratic inequality in one variable is an inequality that can be written in the form ax squared plus bx plus c is less than 0. Now, the less than 0 could actually be placed with greater than or equal to, or less than or equal to. So we're just randomly choosing the less than. To solve these, what we're going to do is we're going to find the solutions to the equation. Set it equal to 0 and find the solutions. Then we're going to use these solutions to mark off intervals on your number line. Then we're going to test a value in each interval. So I get back into the original problem. If that test value works, shade the interval that it's in. If the test value does not work, then don't shade that interval. And then when you're through, all of the shaded intervals form the solution set. Okay, so for instance, we're going to solve x squared minus x minus 12 equals 0. Now I know this one's going to factor, so we're going to do x minus 4, x plus 3 equals 0. Set each of these equal to 0. X minus 4 equals 0, x plus 3 equals 0. So we get x equals 4 and x equals negative 3. So we're going to do a number line and we're going to find 4 and negative 3. Now we're going to pick a number in each interval. Well, I'm going to pick 0 because 0 is between negative 3 and 4. Now when I plug it back in this original problem, I get 0 minus 12, which is a negative 12. Negative 12 is less than 0. So that means I know that I'm going to shade this interval. Okay? If we pick a number over here, let's say we pick 5, and I plug it in here, we would get 5 squared minus 5 minus 12, which is 25 minus 5, which is 20. 20 minus 12 is 8. Is 8 less than 0? No, so we don't shade that interval. Pick a number back here, negative 4. Negative 4 squared is 16 minus negative 4 minus 12. Well, that's 16 minus a negative 4, which is 16, plus a positive 4, which is 20. 20 minus 12 is 8. 8 is not less than 0, which means that one doesn't work either. Now, sometimes it may be real hard to plug those points in, so sometimes what we do is we're just concerned with, is it a positive or is it a negative? For instance, if I plug 0 into factored form, 0 minus 4 is a negative, 0 plus 3 is a positive. A negative times a positive is going to be a negative interval. Let's go back over here to where 5 is. 5 minus 4 is a positive. Any number in that interval would make it a positive. 5 plus 3 is a positive. Well, a positive times a positive is positive. So everything in this interval is going to be a positive. Or if we pick something back here, if we pick a negative 4, negative 4 minus 4 would be a negative. A negative 4 plus 3 would be a negative. So a negative times a negative is a positive. Now look, we're wanting for this thing to be less than 0, which means we're wanting negative intervals, which our negative intervals were only in between these two places. Okay? So we go back and say, okay, does it include the endpoints? Well, because it was less than and not or equal to, we say that the solution would be everywhere between negative 3 and 4, not including the endpoints. Okay, let's do another one. X squared minus 3x minus 18. The first thing we're going to do is look at the equal to 0 case. So x and x, that would give us a negative 6 and a positive 3, and we want to find where those equal 0. So x is equal to 6 and x is equal to negative 3. So what we're going to do is we're going to come down here on our number line, and we're going to mark negative 3, and we're going to mark 6. Okay, that determines our intervals. As long as these are nice, pretty numbers, I think it's easiest if you just go in and plug your points. 0 is between negative 3 and 6. So when you plug in 0, you get 0 minus 18, which is greater than or equal to 0, which means negative 18 is greater than 0. That's not true, so we don't shade that interval. Pick a number over here. Pick 7. Plug it back in. 7 squared is 49, minus 21, minus 18. That would give us 28 minus 18, which is 10, Is 10 greater than or equal to 0? Yeah, so that means we're going to shade this interval. Pick a number back here. Pick -4. -4 squared is 16. Minus 3 times -4, that's going to make that a positive 12. Minus 18 is greater than or equal to 0. So that would give us 16 plus 12 is 28. Minus 18, that one also gives us 10 is greater than or equal to 0. That works, so we're going to shade that interval. Now in this case, because it's or equal to, that means these endpoints do work. They are shaded, so our solution would be -infinity to -3, unioned with 6 to infinity. Now, a couple of formulas involving quadratics. Remember how we said solve for a specified variable earlier? We're wanting to solve for d squared. So the first thing we're going to do is multiply both sides by 4 to get rid of fractions. So if we've got pi d squared over 4, we're going to do this side by 4 and this side by 4. So we get 4a equals pi times d squared. Now we're going to divide both sides by pi. So we get d squared equals 4a over pi. Something squared equals a number. So we can say d equals plus or minus the square root of 4a over pi. If we wanted to go one step further, we could say, well, the square root of 4 is 2, square root of a over pi. Now, this is the end of Chapter 3.3, so you're ready to do your homework on my Math Lab for Section 3.3.